Hi, I'm Townline TB075706 from Computer Science Artificial Intelligence course, intake 2025 September, mentee of Professor Dr. Finish. I'm developing a reinforcement learning-based navigation system for autonomous campus delivery robots. So the problem is that there can be a lot of people occupying the cafeteria, and it can be hard to walk from one block to another. It can take quite some time. So it can take quite some time if we want to deliver from one place to another. So I was thinking a vehicle that can deliver items on a campus would be very useful. So this particular project tackles SDG 9, sustainable industry, and also innovation. And so the main objective is to be able to develop the reinforcement learning algorithms using PPU and SAC, and construct a Unity virtual environment using the APU Campus 3D model provided by our Professor Dr. Finish, and develop an IO navigation agent, and also to test the agent on delivery time, success rate, and collision count. So this is the runtime architecture. So there's a React application that has an embedded Unity WebGL build. So Unity WebGL build is the actual simulation. The reason this is chosen is because we would like to test the application easier, so that when testing, I don't have to think about the operating system of the tester. So that's it for this part, and I will be talking about my project now. So to train the reinforcement learning model, we have to first pre-process the 3D model that we have. It includes several stages. First, we merge the vertices together. Second, we smooth out the faces so that we have less redundant faces. By doing that, we can remove the polygon count from 8 million to 2 million, as you can see here. First, the APU 3D model is split into 4 different mesh, so that we can build a light map for each of them. Light map is for non-real-time lighting for performance purposes inside Unity, so that there is no shadow inside Unity for performance. So the reason for splitting the model into different parts in the first place is because this process of baking takes a lot of VRAM. So it takes around 20 minutes for the entire baking process, and then after the process, we try to combine the model back into one. So now the model can be imported into Unity for usage. So as you can see, this is a training scene, and you have the APU 3D model, and you can also see the training vehicle, 64 of them, equal with LiDAR sensors. So now we can start training with Unity ML agent using the 2 config files inside the config folder, F1V4 and F5V SAC. As you can see, the vehicle now start moving, and it will take over 4 to 6 hours. So we skip. Now in Unity ML agent side, it will produce checkpoints every 100k steps. Okay, so now this is the evaluation scene, where anyone can test out the main feature in the simulation. So as you can see, we are running the PPO model right now, and the LiDAR sensor is enabled. As you can see, it can avoid the obstacle as needed. And now I just show how it can move to another destination. So now this is the evaluation 6-phase feature. Basically, it tries to run through the 3 different types of navigation method every 1 minute for 2 times. So it total 6 minutes, and it tries to also test in different pedestrian scenarios. As you can see, you shall see the result now. So as you can see for the results, the 2 reinforcement learning model, the PPO and SAC model, performs very well in terms of stuck event, because there's less stuck events compared to the baseline A star, and then also less crashes. So that is the result that I found out from this project. Now I'm going to show you how we can run the web-based application of this project. So as you can see, on the right side we have the web interface, and on the left side we have the Unity interface. It's loading. It may take some time. And now as you can see, it's at the APU level 1. And now we are setting a location to go inside the user interface. Now we pay. And now the vehicle will start moving. The elevator is simulated. Elevator will only work in real world if there's an integrated IoT system in APU campus. As you can see, it's navigating, and as you'll see on the interface, you can see the 3D map of the APU. This is now using a real model because it can be quite performant. Now it's moving to the destination again. Now it has been delivered. So from a demo, I think I can say that the aims and objective has been completed, and it really maps into SDG 9, because the project can really help with reducing the time cost by using an innovative method on the campus. And certainly there are a lot of limitations regarding with this project. I believe the main one will be the fact that this project lives inside simulation only and its medium fidelities. If we really want to deploy it in real life, we need to transfer the simulation into a more high fidelity simulator other than Unity. So yeah, that's all about my project.